Hello everyone, it's Benny, and welcome back to the Ultimate Guide to Redstone. In this video, we're going to be talking about a new type of circuit, because we've already covered latches pretty thoroughly, and that also helped us understand some basic circuit design principles, so hopefully this will go a little bit quicker. So, what is this new type of circuit? It's something called a flip-flop. Now, I know that's a little bit of a weird name, but they're not that hard to understand. Mostly because they're pretty much the same thing as latches. There's only a few distinct differences that make it a flip-flop and not a latch. And, in fact, these differences are so subtle that sometimes flip-flops can be confused for latches, so they're not that much different from latches. But the characteristics that they do have that make them different from latches are very important. So what makes up a flip-flop? What makes a flip-flop be different from a latch? Well, in order to hopefully make that a little easier to understand, I've built a little bit of a chart. On one side it has latches, and it lists off everything that makes a circuit a latch. And on the other side it has flip-flops, and everything that makes a circuit a flip-flop. Hopefully that'll make it a little easier to see what's a flip-flop, what's a latch. So, let's go ahead and look at that. So, here it is. Now, let's talk about latches, since we already know what that is. A latch is a device that has two states, and the states are held independently of the inputs. So for example, if I just fly over here to the SR latch, right now the output is 0, and the inputs are 0, 0. So if I flip the latch, if I set it, then now the output's 1, and the input is still 0, 0. This is why the output is held independently from the inputs. A certain input scheme can have a different output. So, yeah. And like we said, it has two states. Either the output can be 0, or the output can be 1. So that's a latch. So, now that we've got a very good idea of what a latch is, if you didn't already, a flip-flop is very similar. It also has two states, and it also has states that are held independently of the inputs. So, like I said, they're not that much different from latches. There's two differences, though. First off, a flip-flop has an enable or an activate command, which is usually called the clock. Yes, and you notice some latches actually have this. So for example, if I fly over to the gated D-Latch or the gated SR latch, you notice, actually I may have modified that a bit, so the gated D-Latch, you notice we have an enable command, and this way the latch won't actually do anything unless the latch is enabled. So flip-flops, all flip-flops have that. So, yeah. They also have one more very distinctive quality. They have something called edge trigger, which, if you've never heard it before, probably sounds really weird. What in the world is an edge trigger? Well, here's an edge trigger. It's basically a specific method for something being activated. So, let me just quickly throw together an example. Okay, so here I have a redstone wire, and I'm going to use this to demonstrate what an edge is. Because an edge is pretty simple. All an edge is it's just a change in redstone power. So for example, right now I have no power in the wire. If I send power to it, that was an edge. It was when the wire went from no power to power. And that's a specific type of edge called a rising edge. Now there's also another type of edge, where if you go from having power to not having power, like this. That created another edge. It's called the falling edge, when you go from power to not having power. So that's all the edge is. Hopefully not that hard to understand. So, all an edge trigger is, then, is it's a redstone device that's triggered only when an edge occurs. So for example, if I had a rising edge trigger, then that redstone device would only work specifically when the rising edge happened. So specifically in that one instance where the power went from nothing to having power, would it happen. It would not keep working once I had power. It would not keep working when I go back to not having power. It would only work in that specific instant where I go from no power to power. That would be a rising edge trigger. I'm sure you can imagine a falling edge trigger would be the same thing, and a dual edge trigger would happen when any change in power happened. So that's an edge trigger. All flip-flops have edge triggers. So, that's all a flip-flop is. It's like a latch, but it has an activate command, which is edge triggered. That's it. That's the only difference. But fortunately, there aren't nearly as many flip-flops as there are latches. There's only about 3 flip-flops that you'll ever see, ever, even in obscure terms, so yeah, not that many. So I'm going to start talking about some of these different types of flip-flops. So, the first flip-flop we're going to talk about is something called the D flip-flop. Now, this behaves, in terms of the way it works, exactly like a Redstone device we've already talked about called a gated D-Latch. In fact, the only thing at all that distinguishes a D flip-flop from a gated D-Latch is D flip-flop is edge-triggered. That's it. That's the only distinction between a D flip-flop and a gated D-Latch. Now, that might not seem like a big distinction, but it's a very important one, because that simple fact of being edge-triggered can make huge differences in certain Redstone situations, which I'll talk about in a bit. But first off, let's go ahead and look at how this thing works. Because even though it works just like the gated D-Latch, it's still good to get the idea in your head. So, we have 2 inputs, a clock, and data. The way this works is, anytime you have the clock, which I should mention this particular D flip-flop is rising edge trigger, but a D flip-flop can be any edge trigger. You can have falling edge trigger, you can have dual edge trigger, any edge trigger as long as it's edge trigger. I said edge trigger way too many times in that sentence. But anyways, anytime you hit the clock, in this case the rising edge, anytime that happens, the output will become whatever the data wire is. So for example, if I do a rising edge right now, regardless of what the output was before, the output will become 0, because that's what the data was at the instant there was a rising edge in the clock. Now if I put the data to 1, that becomes a little bit more apparent, because if I have a rising edge in the clock, you'll notice that the output becomes 1. But you notice, if I start changing this, it doesn't do anything, because I'm not getting a rising edge. If I do a falling edge, that also doesn't change anything, and I still can't do anything to the output. It will only change when there's a rising edge. That's the only instant that the output will change. And that's the key thing with the D flip-flop. It only changes on the edge. So, now let's talk about making one of these. Let's get out of the concept, because I'm pretty sure everyone understands the concept, since it's pretty much a gated D-Latch. Let's talk about the idea of actually building one of these. So, this is a design for a D flip-flop called the Master-Slave design. And I know, it looks a little bit weird, but believe it or not, this is actually a really easy design to build. There's only 2 things that are going into this. 2 gated D-latches. And the gated D-latch I'm using in this looks like this. And before 10,000 people start yelling at me like that this is a Basil flop and it's a D flip-flop, yes, it is, if you make a small modification to it. As it sits right now, if I enable it, the input passes right through. It's not an edge trigger. So you can turn this into a D flip-flop, making a very small modification to the enable wire, but as it sits right now, this is a gated D-latch, and I'm using it for this design. So, let's talk about how this master-slave design works. So, like I said, we have 2 gated D-latches. One of them is right here, which has the data input going into it, and the other one is right here, which has the output of the first gated D-latch going into it. And then we have the clock wire, which just controls the enable of both of them. Now, you notice that by default, one of the gated D-latches is already enabled, the very first one, the one with the data input. So if I send the data input through, it's sort of saving it, but it won't actually hold the value until I disable it. Now the only way to disable it is with the clock wire, so if I disable it, it's now holding whatever value I had. And you notice since the input isn't enabled, I can't send anything else through it. So that's what the first gated D-latch is doing. The second one, if I enable, you'll notice because of course I can't do anything first because it's not enabled, but as soon as I enable it by powering the clock wire, it sends power through. And now you'll notice I cannot change the output like this because the first gated D-Latch is disabled, so therefore nothing can get through. So, the logic's a little bit weird, I know. But it's not that hard of a principle once you get your head around it. In fact, this is actually the exact same principle that makes airlocks work. Once you can let things in, but you cannot let them out unless you first close the way for them to get in. So yeah, same principle as an airlock. You can't let anything get out of it unless you first stop letting things go into it. That's the whole principle that makes this work. Now, what might confuse you is how this is edge trigger. How does this create an edge trigger? Well, simply enough, since we're disabling output as soon as the clock input is hit, then therefore, the output is stuck being whatever the first gated D-Latch was. And you can't change that unless you disable the clock again. That's how it creates an edge trigger. And I'm not going to go into too much detail on how specifically that creates an edge trigger, because there's a little bit of an easier way of doing an edge trigger that we'll talk about a little bit later on. But for now, that's one way of doing an edge trigger. And it's actually a kind of interesting way of doing an edge trigger that I don't see too many people do. Probably because of the, again, slightly easier way of doing it that comes up a little later. But yeah, it's an interesting way of doing an edge trigger, and hopefully that makes at least some level of sense. Again, I'm not harping on this too much because there is a better way that comes later on, but it's an interesting way of doing it nonetheless. And the reason it's called a master-slave design, I think I should have mentioned this, is because you have a master D flip-flop master gated D-Latch that goes into the slave gated D-Latch. And the only way the slave gated D-Latch can be changed is if the master has that value too. Is only if the master says it can it change. That's sort of the logic behind the naming, but again, not that important. So yeah, hopefully you now at least understand a basic D flip-flop design. Again, there's better ones that come along later, but for now, this is the basic. I don't want to go into the other designs because it'll involve talking about concepts that I don't want to cover just yet. But yeah. So, there you go. And now, we're going to move on to another type of flip-flop. Okay, so next thing I'm going to talk about is the JK flip-flop. Now, this is probably the most obscure out of all of them, but there's still plenty of uses for this thing, just not in most common contexts. Now, the JK flip-flop works based on the JK latch, which I have over here. And actually, do I have one built over there? Maybe I do, but I'm not going to search for it. So the JK latch is just like the SR latch, just for a quick review. You have reset and set. The only difference is if you try resetting and setting at the same time, it starts toggling. Now, this is great, but the toggling isn't all that controllable. So, all the JK flip-flop does is it adds an enable or clock line, which is edge triggered. And therefore, that makes the toggling a little bit more controllable, and therefore makes this just a little bit more useful. So, the way this works is pretty much how you'd expect. And I believe this one's rising edge trigger. So if I hit set, yeah, it's rising edge trigger. You'll notice it's setting. If I hit reset and clock, you're resetting. If I hit both, it toggles. And every time I've hit it, it toggles. So yeah, that's the JK flip-flop. Really, not that hard to understand. If you understand the JK flip-flop, or if you understand the JK latch, you can understand the JK flip-flop. So, now I'm going to talk about how to build one. Alright, so now we're going to talk about how to build a JK flip-flop. I'm going to start off with an SR latch. Very simple. And yeah. Now, all I'm going to do here is I'm just going to turn this into a JK latch. So the way I'm going to do this is like this. And this is just using the exact same sort of JK flip-flop design that I, talked about before. Now I need these inverted. And yeah. So there, now we have a very basic JK latch. So how do we turn this into a JK flip-flop? Well, it's actually not as bad as you might think. First off, I'm going to move these wires back just to give us a little bit of room. And right here, I'm going to put my clock line. So these are our inputs. So right now it's just a straight up JK latch. Nothing special. And now we're going to turn this into a JK flip-flop. So first off, to demonstrate something, I'm going to disable these. And I'm going to also disable these, just to demonstrate something. So what I'm going to do is something a little bit weird. I'm going to put a power here, and I'm going to put a torch. Now what I'm going to do is I'm going to send power from this block into both of these wires. And I'm going to send power from the torch into the wires, but on a 3-tick delay. What this is going to do is it's going to send a short pulse for whenever I flip it. And the reason this works is because this will turn off first, and then, since the torch and the repeaters take time, it'll stay turned off for a short while before the torch sends power back into the wires. So we'll just keep them turned off for a short time. And in addition, since this is relying on the torch and the wire, this will actually also act as an edge trigger since it won't send this pulse on the falling edge. So, there we go. So now we have sort of an edge detection system going on. And the thing I just built right there, we'll actually talk a little bit more about that later. That's why I'm not harping on it too much right now. But, so now that we have an edge trigger system, how do we make this into a JK flip-flop? Well, believe it or not, since we're sending this into both inputs, this actually creates a JK flip-flop right here. If I hit right now, nothing happens. If I hit this, you'll notice it'll send a short pulse through. Since this torch is powering this one won't do anything, but this one will turn off. So therefore, this will act as a set command every time, because we'll always disable this. Now, you notice right now it's not disabling it since this is powering it, but that's okay because it's already set. Now, if I reset, I'll have the same phenomenon. It'll send a short pulse through this because there's nothing powering it except the edge trigger system, and it'll reset. Now, if I hit this will send power off both of them, and therefore it will toggle. It'll send power to whichever one whichever one's not powered. So therefore, it's just toggling right now. And there. Now we have a JK flip-flop. Very basic design. I'm not going to talk about too much because it's not really, it's not the most common thing, and it's also talks about some concepts we're going to cover a bit later. But yeah, this is a basic JK flip-flop. Hopefully you at least understand it enough to figure out the rest of the redstone wiring yourself. Because again, I'm going to be talking about most of this stuff a little bit later. This covers a few concepts which I haven't quite gotten to yet. But yeah, there you go, JK flip-flop. Not too hard to understand. And I guess I can try to move on to the next one. So, here's our last flip-flop. It's something called a T flip-flop. This is probably, along with the D flip-flop, the most common flip-flops you'll see. All it does is, as a single input, as a clock input, when you hit it, it toggles. That's it. It'll turn from one state to the other. That's it. Nothing special. So, the way you build this is actually incredibly easy. All you do is you take the JK flip-flop, and you get rid of this, and this. Get rid of the set and reset, get rid of the J and K, and now, oh my god, it's magic. You have a JK flip-flop. A T flip-flop. Well, I really can't say T flip-flop, can I? Well, yeah, now you have a T flip-flop. Because JK flip-flop toggles, now all we have is just get rid of the set and reset options, and now we have something that toggles. A T flip-flop. So yeah, there you go, that's a T flip-flop. I didn't talk about it too much, I know, but T flip-flop is actually a little bit more important. And while I'm here, I might as well talk about something. I know for the past, this whole part on circuits, I haven't really talked too much about how these things are applied. How do you use flip-flops? How do you use latches? Why do you need to know these? When will you come across these? And believe it or not, I do have a reason for that. The reason I haven't been talking too much about how to use these is because, really, it's the type of thing that's just best gone over once you see the full picture. It's like if you're trying to build a tower. If you want to build a tower, your best bet in building it is just taking all the bricks and first getting all the bricks and then building the tower. If you try building a tower if you don't have all the bricks, it's not going to work out too well. It's going to collapse in some places. It'll probably fall over, That's sort of the same principle here. So, yeah. That's the reason why I'm not talking about any of the applications yet, because you're not going to really get the applications, at least as much as I'd like you to, unless you already understand everything you'll need to apply everything. So, that's why I'm holding off. After I've covered the 5 circuits, I'm going to talk all about ways you can use these to build real practical redstone circuits. So, don't worry, there is a reason I'm showing you these things. It's just I'm not talking about them yet, so hopefully you'll understand it better later on. So hopefully you understand that. Sorry for the slightly long video, and well, yeah, see you